If you think a $50 Nvidia GPU can't run games at insane FPS, you're wrong. Today I'm gonna show you how I pushed my $50 Nvidia card to over 240 frames per second in every game. And yes, you'll see the benchmarks to prove it. By the end of this video, you'll know exactly how to make your GPU perform like a beast without spending a single penny. In the first step, press Windows plus R. To open the Run dialog box, type Regedit and hit Enter. This will open the registry editor. Copy the exact path I've given in the description, paste it into the address bar at the top, and press Enter. Once you're inside the correct folder, look to the right side. Right-click in the empty space, choose New, DORD, 32-bit value, and name it WH mode. Next, double-click WH mode, set the value data to 2, and click OK. After that, close the registry editor and restart your PC so the optimization can take effect. Once enabled, your GPU will start processing frame data more directly, which cuts down CPU overhead and improves the way frames are rendered. This results in faster input response, smoother motion, and a much more stable frame rate across every game you play. After booting up, run your usual benchmark or gameplay test, and you'll clearly see the difference. Notice how the frame rate is more consistent, stutters are gone, and everything feels noticeably snappier. Now in the next step, open the Nvidia app. Once it's opened, go to the Settings tab and then switch to Global Settings to configure system-wide performance options. First, set CUDA, GPUs to all, ensuring that every compute-heavy process fully leverages your GPU. Disable DSR factors and DSR smoothness, as these can consume extra resources and reduce FPS. For low latency mode, set it to on to minimize input delay by limiting queued frames. If you're a competitive gamer, you can try Ultra for an even faster response, though it slightly increases GPU load. Enable image scaling to allow games to render at a lower resolution while keeping sharp visuals. Keep the sharpness slider around 20 to 30% for a balance between clarity and natural visuals. Set max frame rate just below your monitor's refresh rate, for example 58 for a 60 Hz display, to stabilize GPU usage and prevent microstutters. Leave OpenGL GDI compatibility and Vulkan/OpenGL. Present method on auto, unless you are running older games that need specific adjustments. For power management mode, switch to prefer maximum performance. This keeps your GPU clocks high during gaming, preventing sudden downclocking and stutters. Make sure shader cache is enabled so compiled shaders are stored, avoiding lag spikes when new effects load. The default cache size works perfectly for most setups. Under texture filtering, negative LOD bias, select allow for sharper textures in fast-paced games, or clamp if you want to reduce shimmering effects. Finally, turn vertical sync, VSync off, unless you experience heavy screen tearing and don't have G-Sync or adaptive sync support, because VSync can introduce unwanted input lag. At this point, you'll notice smoother motion, reduced stutters, and more consistent frame rates. Proof that your $50 GPU is performing far beyond its original expectations. Once you're done, click Apply, restart your game, and enjoy the fully optimized setup. With these tweaks, your Nvidia control panel is now tuned to squeeze every bit of performance from your GPU, boosting FPS and giving you a much smoother, more responsive gaming experience. Now we're going to optimize the Nvidia control panel to ensure the best possible gaming experience, even on a budget GPU. Go to the 3D settings section and select Adjust Image Settings with Preview. Choose Use the Advanced 3D Image Settings, click Apply, and then select Take me there to access all detailed options. The first setting to adjust is image scaling. Turn this off completely, it's unnecessary for FPS optimization. If your goal is better performance, lowering your game's resolution will give superior results compared to upscaling. Since we're focusing on performance rather than visuals, keep it disabled. Next, leave ambient occlusion off. Enabling it reduces shadow quality and consumes extra GPU resources, which will hurt performance more than it helps visuals. For anisotropic filtering, set it to 16 times globally. This sharpens textures without a noticeable performance hit, keeping your game looking crisp while still maintaining smooth FPS. Disable FXAA fast. Approximate anti-aliasing, as it introduces unnecessary blurriness. Instead, rely on in-game anti-aliasing options for a cleaner image. Similarly, turn off anti-aliasing gamma correction. Modern games already handle gamma correction internally, and letting the game manage it provides better visuals. Set anti-aliasing mode to application controlled so your games determine the best method, and turn anti-aliasing transparency off to reduce GPU load. For background applications and max frame rate, enable it and cap it at 30 frames per second. This reduces GPU usage when you're alt-tabbed, improving overall system stability. Leave CUDA GPUs set to all. If you have a single card, for multiple GPUs, ensure your primary GPU is selected. Set CUDA system fallback policy to driver default and disable DSR factor. When it comes to low latency mode, avoid turning it off or using Ultra unless testing shows it improves performance for you. The safest and most consistent choice is on, which reduces input lag without overloading the GPU. Leave max frame rate disabled. If you need FPS caps, do it within the game settings for better control. Disable multi-frame sampled AA, keep OpenGL-GDI compatibility on auto, and manually select your GPU under OpenGL rendering, GPU, to ensure the dedicated card is used. Set power management mode to prefer maximum performance to maintain high GPU clocks during gaming, preventing stutters. For preferred refresh rate, choose highest available to avoid downclocking your monitor and ensure smoother gameplay. Adjust shader cache size between 1 GB and 5 GB to reduce stutters caused by shader compilation. Within texture filtering settings, set texture filtering quality to performance if you want maximum FPS, especially in competitive games. Avoid high quality or high performance settings that can introduce unwanted side effects. Leave threaded optimization on auto, turn triple buffering off, and set vertical sync (VSync) to use the 3D application setting. Enable it in-game only if needed. Ignore virtual reality pre-rendered frames unless using VR, otherwise set it to 1. Leave Vulkan present method on auto for modern game compatibility. At this point, you'll notice smoother frame delivery, fewer micro stutters, and a more consistent FPS. Proof that your budget GPU is performing far beyond its cost. Finally, move to the Program Settings tab, add your main games.exe, and apply the same optimized settings. Power management mode on maximum, low latency mode on, VSync off, and threaded optimization on. This ensures the game always prioritizes GPU power, even if Windows or other programs try to override global settings. After applying these changes, your GPU will no longer sit idle at low usage. Instead, it will push maximum performance into your games, resulting in higher FPS, smoother motion, and a more responsive experience overall. And that's how a $50 Nvidia GPU can hit insane FPS in every game. Smash that like button and subscribe for more epic optimizations.